Hello, I'm JW. This time we're going to have a look at the ConduDisc again. Now I saw this in a previous video where it was just basically shoved in temporarily to get an idea of how it could be used. Readings there were fairly high, but then of course it wasn't actually put in particularly deep and it wasn't compacted down much either. However, this time we're going to be putting this into an actual installation and it's going to be put in properly. Now this is the hole it's going into. And as you can see, it's relatively large. It was dug out with some machine. Some other people did all of that. And this hole is about 900mm in depth, so it's about 3 feet to the bottom there. The black thing that goes across that picture there, that's an unrelated cable for something else. Now we're going to be putting this in, as we've shown here, with the Conducrete as well, and this is a conductive concrete product supplied in a bag and obviously sets hard when it's in contact with moisture, pretty much like any other concrete. So what we've got here is the ConduDisc in the bottom there, and it's been put on top of a fair amount of the Conducrete there, and the idea of this is that it fills in any irregularities in the ground and therefore makes very good contact and obviously a large surface area. So that's it down in the bottom there. Now the wire that came off of this, as we saw in the previous video, is an AWG size or American wire gauge, and it actually works out to about 13mm squared. In this particular case I've just put it in a piece of the steel conduit there. It's just an offcut I happen to have lying around, because in theory it should have some mechanical protection, so just put that over the top of that. And this is a view a bit further back with the bags of concrete. Basically just got one underneath, just on the top of that. And then we have the other bag over the top, so it's completely covered in that. So there it is in the hole itself, and so it's going to be covered over with the soil. Now the soil, as you can see here, is extremely dry. This is basically an agricultural location, and it hasn't actually rained here for several weeks, so as you see, it's very dusty and dry there. So you can see in this final picture I've actually added some water to that, as eventually it would obviously absorb water from the surrounding ground, but that could take weeks, months or even years. But anyway, it's been put in there like that, and again we see the conduit coming at the back there. The green earth wire there is actually going to go into that building behind. That's a brick or concrete block wall of the building it's going to be used for, and then that black cable there is also going into the building for an unrelated purpose. And see, it's just been fixed temporarily to the wall there, preparation for that hole to be filled in. Now I've got a bit of video here, and again we see the hole there with the stuff in the bottom, and that's sort of pretty well covered over at the bottom of that. And so someone else is going to fill this in shortly. Now I've got the MFT 1741 here. Now we're going to be using the 3-wire method, so there's the wires in the back. So the green one there just goes over to the thing we just installed, so fairly obvious, and then the red and yellow go to the temporary electrodes, which are far away over there, and put them as far away as possible. See, that's way off in the distance in the middle of those things over there. So let's just have a look and see what sort of reading we get here. As I've seen before, this does take a while to actually get the reading, but not too bad. So there's the reading, 23.5 ohms, so that's massively lower than the equivalent sort of rod would be. And bearing in mind we haven't even filled over the top of this yet, it's just literally covered over with the conductive concrete. Now here's just a quick view of the length of those wires. As you can see, this is the red one, and then there's the yellow one about halfway along. Again, just stuck in the ground, similar to we had in the garden in the other videos. And then all the way back to the test device over here. Now that's perfectly acceptable for reading, but of course the hole does need to be filled in, and one of the features of this product is, or supposed to be, that over time the reading can actually improve as it obviously increases its contact area with the surrounding ground and whatever. And again, if moisture obviously is going to go into that concrete and cause it to set further, although in this case we did add some water to it anyway. So mainly because the ground is extremely dry and dusty, and hasn't rained here for weeks anyhow. Now we've got another test done here, and this is actually a week later. So basically it was filled in pretty much straight away after that other test was done. The surrounding ground has been compacted down extremely well, and so this is about a week later. So it's going to do another test again. So you can see here it's now covered up with a load of junk because there's some building works going on here as well, so just a load of things being stored there. And you can see in the ground the big tyre marks from the tractor and whatever, which gouged over that with 10 tons of force. Now I've got the temporary electrodes put in again. They're actually going in the other direction this time, so red one far away over there in the middle of that field. And you can actually see the overhead supply there on those poles way off in the distance. The yellow temporary electrodes just over there in that patch of soil. And then we've got the test device here again, so we'll just run the test there. Of course the green lead is connected to the thing underground as we had before. So it takes a while, as we've seen previously. So this is a week later, we're getting 19.9 ohms, so that has reduced by some 3 or 4 ohms there already. And bearing in mind that the previous reading of 23 or so was still perfectly good, but say has actually reduced down to just under 20. So that's how they are supposed to be installed. And again, one of the main benefits of these is, as well as the fact that they can get a considerably lower resistance than just shoving in a metal rod or whatever, the other big benefit is you don't have to then poke rods into the ground and pierce through underground crevices and who knows what else. It's best just dig a hole, shove it in and cover over. And that's certainly, in this particular case, probably not a huge deal because this is, say, a rural location with nothing really under the ground. But certainly in more sort of urban areas, there's likely to be all kinds of stuff buried under there, pipes and cables and who knows what. So although these things are more expensive, they are generally considerably safer and give considerably better results. Now we may test this again in the future because this particular building is being completely rewired and refurbished, so that could be several weeks or months away. And this property also has some rather more traditional rods already installed, so we could do some tests with those and compare as well. But we'll do those at a later date as and when it's possible. And until then, thanks for watching.